Welcome to the deep dive. So for decades, vitamin D has, it's been stuck in this one little box for most of us.
The bone vitamin.
The bone vitamin, exactly. The sunshine vitamin you take if you live somewhere gray. But if that's all you think it is, you're missing, just a massive part of the story.
A huge part.
The sources you've brought together today show it's acting less like a simple vitamin and more like a critical pro-hormone.
Right.
Especially when it comes to fertility and pregnancy.
And that shift in thinking from just a nutrient to a pro-hormone,
Yeah.
that's really the key to this whole deep dive.
Okay.
Because in its active form, it gets deeply integrated into these major signaling systems in the body. It's controlling hundreds of genes.
Wow.
So our mission today is to cut through all the general wellness noise and really connect the dots. We're going to use the clinical research to see how it influences everything from, say, ovulation, all the way to the health of the placenta.
So the actual mechanisms.
The specific mechanisms that make it so foundational.
Okay, let's unpack this. We're going way beyond bone density here.
Way beyond. I think we have to start with the basic architecture of it all. For reproductive health, it's less about just popping a pill and more about structural regulation.
Structural regulation.
Yeah. The research points to 3 foundational areas where having enough vitamin D is, frankly, non-negotiable for fertility.
And I'd guess the most critical starting point has to be the endocrine system.
Always. Hormones.
So where does vitamin D fit into that really delicate cycle?
Well, it starts with hormone regulation itself. It's not just sort of encouraging good health in general.
Right.
It actively helps regulate estrogen and progesterone. And the how is what's so fascinating here.
Okay.
It's because the body has something called the vitamin D receptor, the VDR. And these receptors are physically present in high concentrations in reproductive tissues.
You mean in the ovaries, the uterus?
Exactly. Ovaries, uterus, the placenta.
Yeah.
It proves there's a direct line of involvement.
So it's not just floating around in the system having a general effect. It's physically docking right where the action is happening.
It's docking, and it's acting as a transcriptional regulator.
What does that mean, a transcriptional regulator?
It's basically a genetic switch. When active vitamin D binds to that receptor, it influences how the genes that create estrogen and progesterone get expressed.
So it's turning production up or down.
It's fine-tuning it, making sure that cyclical consistency is there. If your levels are low, that whole signaling chain can just get sluggish or erratic.
And what's the real-world difference for someone who's actually trying to conceive?
The clinical evidence is pretty clear on this. There was a major finding published in the Journal of Clinical Endocrinology and Metabolism.
Okay.
It's specifically linked having optimal vitamin D levels to improved ovulatory function. They saw that when women who were struggling with infertility got their levels normalized, the whole hormonal environment just shifted for the better.
Leading to more regular ovulation.
More regular and more successful ovulation. It's about creating the right internal climate for the whole cycle to just work.
Okay, so if the hormonal timing is right, the next thing you worry about is the quality of the egg itself. How does vitamin D affect that?
And that leads us straight to the second impact area. Ovarian function and, just as you said, egg quality.
Right.
We see this really consistent link between good vitamin D levels and a better ovarian reserve, the pool of available eggs.
Well, it's quality over quantity, right? That's what really matters.
Always. And this is where it gets really interesting, especially for anyone who's, tracking their cycle or even going through fertility treatments. We're talking about the health of the cell itself.
The actual gamete.
Absolutely. The research suggests that vitamin D helps enhance egg quality by influencing the cell's power plants.
The mitochondria.
The mitochondria. You need healthy, energetic mitochondria for that egg cell to have a chance at fertilization. If its energy production is weak, its viability just plummets.
And there's specific research on that link.
There is. A study in fertility and sterility showed this exact connection. Optimized vitamin D didn't just correlate with better reserve markers, but with what they could see were higher quality egg cells.
So it's a deep cellular level benefit.
Exactly.
Okay, so vitamin D is helping the cycle work on time, and it's making sure the egg that's produced is robust. But even the best egg in the world needs a welcoming place to implant. So that brings us to the third piece of this puzzle, which has to be the immune system.
That's right, immune modulation. And this might be the least intuitive role, but it's arguably one of the most critical.
How so?
Well, most people hear vitamin D and they think immune boosting.
Yeah, you take it to fight off a cold.
Right. But for fertility, it's not a booster. It's more like a A highly sensitive thermostat. It regulates the inflammatory response.
A thermostat, not a furnace. Why is that distinction so important when an embryo is trying to implant?
Because genetically, that embryo is half foreign to the mother's body.
Right. It's not self?
It's not self. So an overactive, boosted immune system might actually see that embryo as an invader and attack it.
Which would lead to implantation failure.
Or early loss, yeah. An overzealous immune response is a huge barrier to a successful pregnancy.
So you need vitamin D to gently dial down that defensive response, to tell the immune system, hey, it's okay, let this one in.
That is the perfect way to describe it. It promotes these special cells called regulatory T cells, or Tregs.
The peacekeepers.
The peacekeepers, exactly. They suppress those damaging inflammatory responses right at the uterine lining, creating a balanced receptive state. A review in autoimmunity reviews really highlighted this function, cementing its role in preventing these kinds of issues.
So it's a multi-level foundation. It's balancing the hormones for timing, it's improving the cell for robustness, and it's preparing the immune environment for acceptance.
It's working across 3 completely different biological systems at the same time.
Okay, let's shift gears, because here's where it gets really interesting for me. Once conception happens, once that embryo implants, vitamin D's job isn't over.
Not even close.
It totally changes roles. It goes from, helping get pregnant to helping stay pregnant and keeping that pregnancy healthy.
The demands just skyrocket, both on the mother and the developing fetus. And the need for vitamin D becomes even more critical for development.
Let's start with the actual building blocks. We all know it's for bones. But how does the mother's vitamin D supply directly affect the baby's structure?
Well, during pregnancy, the fetus is 100% reliant on the maternal supply.
Of course.
And it is absolutely essential for its structural development. And yes, that means calcification of the skeleton, forming teeth, the foundation for lifelong bone health.
But I'm guessing it's more than that.
It's much wider. We're also seeing that it supports the healthy development of the fetal immune system and even early brain and lung development. It's setting these long-term health trajectories before the baby is even born.
So you're not just building the chassis of the car, you're helping to pre-program the defense system and the central computer at the same time.
Precisely. And a really key study on this was published in the American Journal of Clinical Nutrition. It confirmed just how crucial the mother's vitamin D status is for healthy fetal bone development and just overall growth.
And all of that support, all of those nutrients, they're being delivered through one organ.
The placenta.
The placenta.
And that's the next key area. Vitamin D directly contributes to the health and the functional efficiency of the placenta itself.
So if the mother is deficient, the actual life support system for the baby is compromised from the start.
That's the risk, yes.
Yeah.
If that placenta isn't working at 100%, the delivery of nutrients and oxygen can slow down. And that can have these cascading effects on growth.
So what's the specific job of vitamin D inside the placenta? What is it doing?
Research from the journal Placenta shows it's vital for supporting the placental architecture. Specifically, it helps regulate something called angiogenesis.
Which is the formation of new blood vessels.
Exactly. You need that to create this huge, robust network for transfer. It also helps control inflammation within the placental tissue, which helps it stay healthy for the whole 9 months.
That makes perfect sense. A healthy circulatory system in that organ is the bottleneck for everything.
It is.
Now, beyond just development, the sources you brought really highlight a powerful protective role against some of the scariest complications of pregnancy.
Yes. And this, I think, is maybe the most compelling reason for everyone to pay attention to this.
We're talking about things that affect millions of women and can be really dangerous.
Absolutely. Adequate vitamin D levels are strongly associated with the reduced risk of 3 of the most serious and common complications.
What are those 3?
Gestational diabetes, preeclampsia, and preterm birth.
Okay, let's just take one of those. Preeclampsia, what's the mechanism there? How does vitamin D help?
So preeclampsia is a disorder of high blood pressure. And vitamin D is involved in regulating the systems that control vascular tone and blood pressure. By helping maintain healthy blood vessel function and reducing inflammation system-wide, it can sort of temper the conditions that lead to that dangerous spike in blood pressure.
So it's influencing the body's core systems for managing pressure. What about gestational diabetes?
For that, it's known to influence insulin sensitivity. Keeping your levels optimal just helps the mother's body process sugars more effectively. It reduces the odds of developing the insulin resistance that causes the condition.
And we have solid clinical evidence for this protective effect, for all three of those risks.
We do. There was a huge meta-analysis in the Journal of Clinical Endocrinology and Metabolism.
Okay.
It pulled together data from multiple studies, and the conclusion was definitive. Adequate maternal vitamin D status measurably reduces the risk of all three: gestational diabetes, preeclampsia, and preterm birth.
So this really moves the conversation from vitamin D being something that's just good for you to something that is actively mitigating known severe risks.
It's a risk reduction strategy, absolutely.
Yeah.
So if we synthesize all this detail we've just unpacked.
Right, let's tie it all together.
Vitamin D is clearly not a single-task nutrient. It's a foundational player across the entire reproductive journey. It's working on the endocrine system by regulating hormones.
For timing.
It's working on the immune system to ensure acceptance and implantation.
You're welcome.
And it's ensuring structural success by building the fetus and supporting the placenta. It's a true multitasker.
So the conclusion for you, the listener, is really clear. Maintaining optimal vitamin D levels isn't just for general health. It's essential for, first, optimizing your chances of conception. And then, for giving that baby the healthiest possible, start by acting as a shield against major complications.
And getting to that optimal level is pretty straightforward. You have three main routes: sunlight, diet, and targeted supplementation. But knowing the why, knowing that this choice affects mitochondrial health in an egg cell and blood vessel formation in the placenta, it just elevates the whole thing. It's not just a habit. It becomes a physiological necessity.
You know, when we talk about vitamins, we so often think about just avoiding old diseases like scurvy or rickets. But when you understand these intricate roles that one single molecule can impact genetic switches for hormones, manage immune cells at the uterine wall, and regulate blood vessel growth in the placenta, it just highlights how foundational this is.
It does.
It makes you realize how incredibly complex and fine-tuned life is, and how these seemingly small inputs can regulate these vast biological processes.
And understanding those details, connecting the molecular mechanism to the clinical findings in those big studies, that's what moves you from just having basic knowledge to being truly well-informed on a topic this important.